Hey everyone, welcome to week 4 of our Davis. We've made it to the exciting part about data manipulation in R, and we're going to be learning about how to use various packages within the Tidyverse. So if you haven't already, please check out Liza's video from week 3. I think it was the last video, and it covered installing the package Tidyverse and all of the suite of packages that come with that umbrella package. And also, if you want to read up on some more information about what I'm going to be sharing in this video and what other videos we'll cover later this week, please go to our website and check out Lesson 6, Data Manipulation, Part 1. So the learning objectives for today are going to be going over what dplyr and tidyr packages are. And then specifically, we're going to dive into some functions within the dplyr package. So this includes select, filter, and then this operator that is specific to Tidyverse called pipe. And it's basically a way of linking multiple functions together. Okay, so let's first load in our package that we're going to be using. So I'm just going to call this setup. So library, Tidyverse. And if you don't have Tidyverse installed already, I'm just going to throw one more plugin for Liza's video because that will show you how to do that. And once you've installed it once, you should be able to just use the library function to call up this package into your global environment to use in the script. And so, as I mentioned, we are going to go over tidyr and dplyr, these packages specifically down here. At some point in this week, I'm going to be focusing on functions from dplyr itself. And dplyr is really nice because it provides a lot of tools for common data manipulation tasks, like selecting and filtering. Tidyr is nice because it's really good for converting between different data formats that can make plotting and analysis much easier. And so it's basically a way to reshape your data. And one resource that I like to tell people about is the tidyr and dplyr cheat sheet. So go to this link to check that out. I still reference it all the time. It's really good at showing you common functions in these packages and then visualizing what they do to your data. So now we're going to get into the actual lesson material. So first, let's upload our data. And you might notice that I'm using this, I guess, syntax, you would say, with a hashtag and 4 dashes. And the reason I'm doing that is just to stay organized in my script, know which section I'm talking about. It also tells R that these are headers of sorts. So you can go over to these horizontal lines and click on them, and it'll show you the headers. If you don't want that to take up space in your script, you could also just click down here and it has them. It also gives you this functionality, which is kind of fun, that you can you can like up the arrow so all this information isn't taking up space. So it's like, okay, we're already set up. We don't really need that information anymore. So that's an option. I'm going to leave it out for right now, but yeah, so we're going to upload our data. So this is going to be the same data that we've been working with. And because we're working in the Tidyverse, we're going to do read_CSV. So file equals data, and then this portal. I gotta look because I can't remember the name here. So portal data joined.csv. We hit run. Let's check out what our data frame looks like. Okay, cool. We have a tibble here. We have just an example of some of the columns, not all of them. we have their data type, and then we also have NAs for all of the blank rows of information. Okay, so the first function we're going to learn from the dplyr package is select. So we've already been selecting data, we've been indexing data, subsetting data. Now we're just going to learn the Tidyverse version of doing that. So we can actually just use a function called select, and say we want to select data from surveys T. Okay, well, it's returned to us that, we have all these rows of data, but I have not specified any sort of columns, so it hasn't selected any. So this tells me that we actually do need to specify the columns that we're interested in selecting. I want to point out, when I type out the function, it pops up here and it's like, hey, this first argument is your data frame. So .data, and that's why I've been typing in surveys T, and it knew where to look. And so I can be a little more clear about that and just say .data surveys T, or you can just write it on the left side of this first comma and it will know. Select is also quite usable, like friendly to use, because you can just type in the columns that you're interested in. So let's see, I had some notes on specific ones I wanted to pull up. I think we want plot ID, species, ID, and weight. Okay, so we do this, but wow, there's a lot of rows here. But Tibble is kind of nice in that it follows a similar format that we saw earlier. And we can see here, it successfully selected these 3 columns that we were interested in, and it tells us, their data type and NAs. If you did want to nest this within the head function, you absolutely could. You could do, head select surveys T, plot ID, species ID, and wait. Run that, and it's nice and neat. So that's the select function. Now let's go over filter. So filter works very similarly. So when we type filter out, it tells us, again, the first argument is your data frame that you're going to be pulling information from. And then it has some other arguments that if you want to look into, you can. So we want a surveys T file here. And let's say we want to select for data from the year 1995. So we set the double equals, as in that means, is equal to. We look up here, and in fact, it's selected all 1995. What if we wanted to select everything but 1995? We can go year, exclamation mark equals. And here we go, it selected all these other years. Okay, so that is selecting filtering. But what if we want to combine both of those together? This is where pipes, as I briefly mentioned earlier, come into play. So pipes are an operator. They take this format, and this might look obscure at this moment, so I'm going to actually walk through a couple different steps of the logic, and then we're going to end with this operator, and hopefully it will make sense to you exactly what it's doing. Okay, so let's see. We want to filter and we want to select. Okay, so let's start with naming an object, surveys 2. And let's select from surveys T. Let's select the same columns, actually. Let's do plot ID, species, ID, and weight. Okay, Let's also filter out, I'll call it small for all of the small weights. So let's do filter, surveys, T, and then weight less than 5. Okay, so we've done this. And now I'm actually wanting to combine it so that it's all in one spot. So what I could do, and what I should have probably done to make this a little more clear, is actually just used this filter function. Use the select function to call out surveys small in here. So the way that we can do this is, let's do surveys to filtered. And so we have, select from surveys, small, plot ID, species, ID, and weight. And when we do this, we can look at what the results show here, but we have selected all of the weights, less than 4. So here, that's a little confusing of the order, but essentially you are selecting from your filter data, which our filter data here is this data set. And then, we select these columns from that. So another way that you could do this is actually by nesting the functions within one another. Okay, so let's see, let's do surveys. Filtered, second option. We could go select, and then before, how we had it was select from this data frame here, and instead of actually placing this data frame, we could just place this function that we wrote here inside of the select function, and that way it's performing the task altogether. So we have select, we have filter, we have our data frame, we want all weights below 5, and we want it to select the following columns. We want plot ID, we want species ID, and we want weight. So we go, and if we're curious if this pulls out the same exact data set as the other method, we could go identical surveys to filtered, surveys filtered to. Let's see. Yes, they are in fact identical. So you can see that both of these processes worked for selecting and filtering our data. So this is where an additional way to do this comes into play with pipes. And pipes are useful because they provide a way to do it all in one section of code that you can run together. Okay, so let's do pipe example. And I'm actually gonna just do this as a subset of the pipe. So when I look at my outline, we have pipes and we have pipe example down here. So that's just a side note if you're wondering how to organize and why I'm typing my syntax the way I am. Okay, so let's call it survey filtered pipe. And so the way this works is first you need to establish what the initial or original data frame is that you're going to be pulling data from. So we have surveys T, and then we're going to put in this symbol that looks like a %, a caret, and a %. And there's a couple of different ways to do this. There's some keyboard shortcuts like Control Shift Enter if you're on a PC, or Command Shift Enter if you're on a Mac, or you can just type it out, whatever you prefer. Okay, so we have surveys T, and then we want to filter the data. So we put in our filter, and I type in weight less than 5. And then we also want to select for, let's see, we have plot ID, species, ID, and weight. Hit run, and this has in fact now created a new data frame. So let's check it out. Filtered pipe. And this should look exactly the same as our previous data frame. So what is happening here? Let's dissect this a little bit. So we basically have taken what we did in the previous two options here, you know, the single lines of selecting and filtering, the nested lines of filtering and selecting, and now combine them all here. And essentially this pipe function could be replaced with the word then. So R is seeing this as, okay, we have the data frame surveys T. Then I want to filter all of the data where weight is less than 5. Then I want to select the columns, plot ID, species ID, and weight that came out of that filtering process. And so because of this, R is seeing the left side of the pipe as the data coming in, and the right side as the function to process that data. So because of this, we no longer have to specify our data frame here. In fact, this would throw R off if we were to do this. We get an error because it is confusing R with what data you're talking about. You could, if you want to continue with the idea of arguments and having everything specified, you could put a period and then the comma, and it works. And so sometimes you will have to do this when you're working with pipe functions, but for now, we're just going to leave it without that to keep it simple. And then if we want to verify that what we've created with this pipe function is the same as what we created by, say, nesting, we can do the identical. And we have, let's see, surveys, filter 2, and then surveys, filtered pipe. And yes, they are in fact the same exact. Okay, so that is all that we're going to be doing for today in this video. But check out the other ones, and I look forward to talking through this more in class.